Continuing our exploration into trigonometry, we are going to be talking about solving a right triangle in this section and applications of a right triangle, including finding a bearing of an object. Say we have a right triangle with given sides and certain angle lengths. In this right triangle, the angles A, B, and C must sum to 180 degrees. And the side lengths A and B, when they're squared, must sum to the hypotenuse squared. Remember these 6 trigonometric functions: sine, cosine, tangent, and their reciprocals. For a given angle, theta, sine is the opposite side over the hypotenuse, cosine of theta is the adjacent side over the hypotenuse, tangent of theta is the opposite side over the adjacent side. Cosecant is the hypotenuse over the opposite, secant is the hypotenuse over the adjacent, and cotangent is found by taking the adjacent over the opposite. These are the common trigonometric ratios that we have to solve this right triangle. When I say solve a right triangle, that means find all the missing values. If you have two sides that are known or an angle and a side that are known, you can either use the Pythagorean theorem to find a missing side, or you can use one of the trigonometric functions to find the angle that you're missing or the side lengths that you're missing. Solving means you have all three sides now known and you have all three angles known. In a right triangle, one of the angles is going to be 90 degrees, and you're either going to have the two other angles or one other angle. So you're going to need to solve and have 6 values total. One is going to be a 90-degree angle, and then you'll have 2 other angle measurements, and then you'll have 3 side lengths. Trigonometry was developed in order to be able to measure distances that were difficult or impossible to measure. Say you're at the Statue of Liberty and you don't know how tall the Statue of Liberty is, and you wanted to determine if you were in a boat off the island, you could know how far away you are from the Statue of Liberty, and you might be able to know the angle of elevation. You could then use trigonometry to find out how tall that Statue of Liberty is. Another example is, let's say you have a ladder leaning up against a building. You know how tall your ladder is, you know how high up the building it is, and you want to know what your angle of elevation is. Or you know the length of your ladder and you know how far away the ladder is. You could determine how high up the ladder is or the angle of elevation as well. Computing the bearing of an object is used to convey the angular relationship from one point to another. So if you have 2 points, the bearing is the degree measure of the acute angle formed by the ray and the north-south line. So it's all in relation to the north-south line. When we have our unit circles and we're drawing reference angles, those are in relation to the horizontal x-axis. Bearings are computed north-south, which is the y-axis. Here's a drawing of an image where we have 4 different rays. We have ray AB, ray AC, ray AD, and ray AE. Each of these is in a different quadrant. I have drawn out the different directions, north, east, west, and south. The north-south line is the one that is horizontal. The north-south line is the one that is straight up and down vertical. Each of these rays has an angle that would describe the bearing from that ray to the north-south line. So for the ray AB, the angle of bearing would be from the green line to the north-south line. The ray AC would be going from AC up to the north-south line. AD would be going from the blue line to the north-south line. For ray AE, you're going from the ray to the north-south line. So those are different, again, than the unit circle where you're going in relation to the horizontal axis. Bearing is going towards the y-axis. A bearing is denoted by the letter north or south, and then followed by the degree, and then east or west. For the angle in the first quadrant, that ray, AB, is going to be north because it is above the x-axis. It is positive y, so that's going to be north. And then whatever the degree measure is, let's say it's 70 degrees, and then east because it's heading to the right. Ray AC, that angle is described by north, again, because we're talking about positive y, and the angle would be about, let's say, 72 degrees. It's a little bit larger than the first angle, and then it's heading west. For ray AD, we have a smaller angle than before. We call that about 40 degrees. It is going negative y, so that is south, 40 degrees west, because it's heading towards the left or towards the west angle. That is the direction. And then for AE, the angle is even smaller, but it is in the negative y, so that's south. We'll call that 30 degrees heading towards the east. So notice that each quadrant, if you're heading into quadrant 1, 2, 3, or 4, gives you a different measurement. You're either northeast, northwest, southwest, or southeast, depending on the quadrant that you're in. The direction in which you're headed also makes a difference. We want to calculate the bearing from A to B. In order to do this, we are not talking about from the origin B to A, we're talking about from A to B. So we want to draw a coordinate system at the origin point. So I'm going to sketch a little coordinate system here. And from A to B, the angle measurement in relation to the north-south line, remember we are going A to B, it's like the blue ray that I drew AD on the other drawing, that one that was south 40 degrees west. We're doing that from our little coordinate system here that we see. What is that angle measurement? Well, we made a triangle. All the angles in a triangle have to sum to 180 degrees. We know that one of these angles is a 90-degree angle. That means that the 25-degree angle is complementary to the angle I'm trying to figure out, my bearing angle, which makes it 65 degrees. My bearing from A to B then is south because I'm below the x-axis, 65 degrees, west because I'm heading into the negative x's. The main thing to consider when you're calculating bearings is you have to go in relation to the north-south line. These problems can get a little trickier though when you're talking about, let's say we have a boat that travels north for a little bit and then travels west for a little bit, and then we want to know what the bearing is in relation to the dock, or a plane is flying south and it meets another plane at a certain direction, well, hopefully not there, but you have to consider the speed at which things are happening, the distance that they're traveling, and the angle measure. So definitely check out the skill practice to see the different types of problems you can encounter and how you can calculate them using this base idea that your bearing is in relation to the north-south line, and then your angle is in degrees in relation to then the east-west line.